Okay, we'll begin. So on Monday, we talked about numeric summaries for numeric data. Okay, and on Monday we covered the mean, which describes the center of a sample of data, and we described the standard deviation. And what does the standard deviation describe? The spread. So the standard deviation describes the spread of a sample of data. And with this information, when we know the mean and we know the standard deviation, we can start to describe and try to figure out whether an observation is unusual or not, if it's a quote normal or ordinary value, or if it's an unusual value. Okay, and this can be done via the use of z-scores. Okay, so the z-score of an observation is the observation's distance from the mean expressed in standard deviations. Okay, so let's try an example here. Let me just scoot this up a little. So let's say in the United States, the heights of adult women have a mean of 64 and a standard deviation of 3. Okay, and in reality, the numbers are different, but just for simplicity, we're going to keep these nice, simple numbers. Okay, so we'll say in the U.S., the mean height of adult women is 64 inches. Okay, so that's 5'4". The standard deviation of heights is 3 inches. Okay, again, real numbers are different, but for simplicity, we'll just keep these nice, easy numbers. Okay, and so keep in mind the z-score of an observation is that observation's distance from the mean expressed in standard deviations. Okay, so we'll say a woman has a height of 67 inches. Okay, what is this person's z-score? Okay, so her z-score is 1. Okay, so, you know, her height of 67 is 3 inches above the mean. Okay, the mean is 64. Her height of 67 is 3 inches above the mean. Each standard deviation is 3 inches. Okay, so she is 1 standard deviation above the mean. So therefore, her z is 1. So far, so good? Okay, let's try another one. Okay, so we'll say another woman has a height of 59.5 inches. Okay, and we're going to ask, what is her z-score? Okay, so what do you guys think for this one? So she is what? So her height of 59.5 is 4.5 inches below the mean. Okay, so if her height is 4.5 inches below the mean, how many standard deviations is that? That's 1.5. Okay, so 4.5 is equal, 4.5 is 1.5 standard deviations. And because her height is below the mean, her z-score will be negative 1.5. Is that okay? And so I can give you a formula for z-scores. Okay, so the z-score formula. So again, the z-score is the distance from the mean expressed in standard deviations. So we will say z is equal to x minus x bar divided by s, okay, or x minus the mean. This is the numerator, x minus mean. This is the distance from the mean. But then we take that distance and we divide by the standard deviation. The distance from the mean divided by the standard deviation. So that would be our z-score. That's how we find z-scores. We take the distance from the mean and we divide that by the standard deviation. All right. So, why would we bother trying to find z-scores for anybody? Okay, what benefit does it do us to say, okay, this woman who has a height of 67, her z-score is 1. Okay, well, we have something called the empirical rule. Okay, and the empirical rule is based on z-scores. Okay. The empirical rule applies to most data sets applies to most numeric data sets and is especially true if the data is unimodal and symmetric. So if it's unimodal and symmetric, the empirical rule holds very true, okay, is very accurate. And the empirical rule goes something like this. It says for, we'll say about 2/3 or about 68% of data is within 1 standard deviation of the mean. Or another way of saying that is to say that, 2/3 of the data, their distance is 1 standard deviation or less, or in other words, we can say about 2/3 or about 68% of the data have z-scores between -1 and 1. Okay, about 68% of the data have z-scores between -1 and 1. There's 3 parts to the empirical rule. The next part says about 95% of the data is within 2 standard deviations of the mean. Or we can say, about 95% of the data have z-scores between -2 and 2. Okay, so let me just so far I've only done 2 out of the 3, but let me just kind of illustrate what these things are saying. So what we're saying is that, where is z-score -2? Okay, so for adult women, okay, so adult women, again, the mean is 64, and the standard deviation is 3. Then the z-scores of -2 and 2, so for z equal to -2, this means we are 2 standard deviations below the mean. So we could say z is equal to -2. This would give me a value, if I go 2 standard deviations below the mean, I would go 64 minus 2 times 3. 64 minus 6, this takes me to 58. And then for z equal to +2, then I would do 64 plus 2 standard deviations, 2 times 3, each standard deviation is 3, so that gives me 64 plus 6, this gives me 70. And we would say something like about 95% of women have heights between 58 and 70 inches. So about 95% of women are between 4'10" and 5'10". That's what this says. Okay, about 95%. About 1 in 20 would be outside of that range. Okay, and likewise we could do something similar for the 2/3, and that would be, about 2/3 of women have heights between 61 and 67. That's Z, 1 standard deviation below and 1 standard deviation above. Okay, so the last part to the empirical rule is almost everyone, okay, about 99.7% is within 3 standard deviations of the mean. Or we'd say, or have, almost about 99.7% have Z between -3 and 3. Okay? And so because of this, the empirical rule is also known as the 68, 95, 99.7 rule. Because about 68% is within 1 standard deviation, 95% is within 2 standard deviations, 99.7 is within 3 standard deviations. Is that okay? No questions? We're all good? Yeah, question.
What would be the margin of error?
What do you mean the margin?
Would it be -1, or would it be between the +1 and the -1 standard deviation, or just the mean and -1?
Wait, I'm sorry, maybe I don't understand. We're saying about, it's between -1, Z is -1, and Z is +1. So that includes everything in between.
So that whole thing is the margin of error?
We don't call this the margin of error. We just say within this span. Okay, from -1 to 1, we have about 68%, about 2/3 of the data. Okay, or between -2 and +2, we have about 95%. Okay, so in our example, we found the heights that correspond to Z's of -2 and +2. So we say if we go 2 standard deviations below the mean, that's 64 minus 2 times 3, each standard deviation being 3. So we do 64 minus 6, that takes me to 58 inches. 64 plus 2 standard deviations takes me to 70 inches. So we say about 95% of the data, so about 95% of adult women in the US have heights between 58 and 70 inches. About. Okay? Something around there. Okay, let me keep going here. And so this is the empirical rule. A benefit of the empirical rule is we can start to have guidelines for what can be considered unusual. Okay, and so we'll say if an observation has Z greater than 2 or Z less than -2, okay, so more than 2 standard deviations of the way from the mean, we say it is unusual. Okay, and if an observation has Z greater than 3 or Z less than -3, we say it is highly unusual. Okay. Another benefit of Z-scores is that you can start making comparisons between observations from different groups. Okay. Okay, so for example, so you can compare apples to oranges if you turn them into z-scores. So here we'll do an example. This will be kind of our first clicker question for today, and we will say which of the following is more unusual. Okay, and we'll say a Great Dane. So we're talking about dogs here. So Great Dane is it's like a Marmaduke, okay? A Great Dane that weighs 190 pounds, or a Chihuahua that weighs 9 pounds. Okay, and so I went and I looked up information on some dogs here, and so for Great Danes, the mean is 160 pounds, and we'll say the standard deviation is 20 pounds. Okay, for Chihuahuas, the mean is equal to 5 pounds, and the standard deviation we will say is 1.2 pounds. Okay. And so the question is, which of these is more unusual? What you're going to do is you're going to find the z-score for each of these, and whichever z-score is farther from 0, that is the observation that is more unusual. Okay, and so your answer choices, we will say A is Great Dane, more unusual. B will be the Chihuahua is more unusual. Or C will be neither is more unusual. Okay, so if you're watching on the video, I'm going to pause right here, but I'm going to open up the clicker poll. All right, you want to make sure that your clicker is set to frequency AA. That's kind of the default, and when you power on your clicker, it should say stats 10 if the frequency is set to AA. Okay, if it doesn't say stats 10, then you hold down the power button, and then you click when that frequency starts flashing, you click A. You click A twice, and then it should say we recognize the base. Okay. So if you need to talk to a neighbor, you can do that. And again, I'm going to pause the video here. Okay, and so yes, this is the correct answer is that. All right, and so I think you guys all did this, and that's why you guys got the correct answer. But first, we would find the z-score for the Great Dane, and so the z-score would be x minus the mean divided by the standard deviation, and so we say our observation is 190 pounds. The mean is 160. Each standard deviation is 20. So this Great Dane is 30 pounds above average, but each standard deviation is 20, so the z-score for the Great Dane is 1.5. For the Chihuahua, we do something similar, and we say this Chihuahua weighs 9 pounds. The mean is 5, and each standard deviation is 1.2. This Chihuahua is 4 pounds over average. 4 divided by 1.2 gives me 3.33. So the z-score for the Chihuahua is 3.33. We said anything with a z-score over 3 is highly unusual, whereas the Great Dane has a z-score of 1.5. So it is above average, but it is not very, very unusual. Okay, so z for the Great Dane is 1.5 versus Z is 3.33. Therefore, the Z-score for the Chihuahua is farther away from 0 therefore it is more unusual. All right, so far so good? Okay, so that covers the usage of the mean and the standard deviation and the appearance of z-scores. We will see z-scores again in a few weeks here, and they will play a very important role in the course. All right, let's talk about the other numeric summaries or other summary statistics that we have. We have the median and the IQR. And we might say that these are summary statistics that we may prefer for skewed data. Okay, and so the median describes the center. Okay, so the mean and the median, they both describe the center. We said the mean was the balance point of our data. The median can be thought of as the halfway point of our data. Okay. The median is going to be the location where half of the data is less than or equal to the median. Less than or equal to the median. Or we can say it is the 50th percentile. Okay, 50th percentile means that 50% of the data is smaller than the 50th percentile. Let me also introduce these other parts. The first quartile. The first quartile, we call this Q1. And Q1 is the 25th percentile. And we say that 25% of the data is smaller than Q1. Okay? 25% of values are less than or equal to Q1. Okay? So Q1 is the 25th percentile. The median is the 50th percentile. Where would the third quartile be? Q3, this is the 75th percentile. So the spot where 3/4 or 75%, third quartile, 3/4 of values are less than or equal to Q3. Okay. So these are kind of some definitions here. And the IQR, this is the interquartile range. this is equal to Q3 minus Q1. The distance between Q3 and Q1, that's the IQR. The distance between Q3 and Q1, that is the IQR, or the third and first quartiles, and this is just another way to measure spread. So we have the standard deviation can measure spread. The IQR is another way to measure spread. Kind of the distinction is that the median and IQR are not affected by extreme values, whereas the mean and standard deviation are. Okay, so the median so if you want a measure of center and a measure of spread that is not affected by extreme values, then you can use the median and IQR. However, if you want to take into account that these extreme values exist, then the mean and standard deviation will account for those extreme values in there. Okay? And that shows up. Right. This is okay? Can I flip to the next slide here? All right, so let me just kind of give a little practical example of how the median and Q1 and Q3 and all of that works. Okay, so just imagine we have a classroom with 180 students. Okay, and let's say the variable that we're going to collect is how much money is in your bank account. Yeah, I don't know, okay? And so, this distribution is skewed right, yeah? Because we're going to have, some people might have a lot of money in their bank account, and so they would be on the extreme high side. Whereas, most college students, that is not the case, okay? And so, yeah, I'm going to just make up some numbers. I don't know. What do you think the median amount in the bank is? I don't think it's going to be 0, but, huh? I'll say $604. I don't know. Median, okay? In your bank account. So, I don't know. I'm just making this up. All right? Maybe this is a dream. All right. So what this means is that half of students, so that's 90 students, have, $604 or less, okay? 90 students, half of the students have $604 or less, and half of the students, the other half, have 604 or more. Okay. That's the median, okay? And then, let's just say, Q1, the first quartile, is going to be $160, okay? So this means 25% of students, so 25% of 90, that's 45 students, have 160 or less, okay? Okay, 25% of students. All right. Q3, I'm just making up numbers here. Let's say this is 1740. Okay. So this means 75% of students. So that would be 3/4, 135 students. Have, money less than or equal to 1740. Is that okay? So the IQR is 1740 minus 160. 1740 minus 160, 1580. So if these are our numbers, our IQR is 1580, and that means the difference between kind of the top quarter and the bottom quarter, difference between the, we'll say the Q3 and Q1 is 1,580, okay? How many students have between 160 and $1,740 in their bank account? So how many students have between this amount? Okay, well, we have 135 that have less than 1740, and I've got 45 that have less than 160. So that means we have 90 students between. Okay, we have 90 students between these values, and so that means kind of your middle 50%. Okay, half of the students have amounts between these two numbers. So the IQR, you can think of this as the range of the middle 50%. The IQR can be thought of as the range how many students have between 604, the median, and Q3, 1740? Yeah. How did I get 90? Okay, so what I said was 135 have less than 1740, okay? And 45 have less than 160. So if I want to know what's between 160 and 1740, I can just take away these 45 from 135, and that leaves me with 90. Okay? So using kind of the same idea here, if I say, well, how many students have between 604 and 1740? Whoops, guess I should plug in. The difference there would be 135 minus 90, or basically 1/4 of my data, and that would be 45 students. So I would have 45 students between 604 and 1740. Okay, so you'd have, so basically 25% between the median and Q3, and likewise you would have 25% between Q1 and the median. Okay. Any questions? We're all good? Yes.
So the median is 50%.
Median is the 50th percentile. Okay, meaning that 50% of the data is smaller or equal to the median. All right. So let's talk about finding the median. Okay, we're going to run out of time, so we'll say finding the median and IQR. step 1, and this is very important, most important, arrange from least to greatest. Arrange your values from least to greatest. Okay, so let's say I do that, and the values for 12 test scores, I've got 12 test scores, and let's say these values are 60, 70, 72, 77, 78, 80, 83, 85, 88, 90, 92, and 97. Okay? So to find the median, median is the location where n over 2 values are smaller, and n over 2 values are larger. Values are larger. So how many values I have? I have 12. So n is equal to 12. Therefore, n divided by 2 is equal to 6. So I'm going to find the spot where 6 values are smaller, and I'm going to count 1, 2, 3, 4, 5, 6, and I'll draw a dotted line here. So I've got 6 values that are smaller than this location, 6 smaller, and if I count over here, I've got 1, 2, 3, 4, 5, 6, and I have 6 larger. So my median goes right here, and if n is even, then the median is going to be equal to the average, or the mean, of the middle two values. So in my case, my median is equal to 80 plus 83. These are my middle two values. I divide that by 2, and I get a median of 81.5. We do the same thing to get the quartiles. To get the quartiles, we find the quote median of each half. Okay, so it's just like cutting a sandwich, or if you have a big sandwich and you want it in quarters, you cut it in half, and then you take each half and you cut those in half again, and you get quarters. Okay, rather than trying to quarter it up from the beginning. So we have 6 values that are smaller. Half of 6 is 3. I want the spot in where I've got 3 on this side and 3 on that side. So therefore my Q1 is going to be 72 plus 77 divided by 2. This gives me 74.5. Same thing over here. I've got 6 numbers over here. I find the spot where 3 are smaller and 3 are greater. 3 that way, 3 that way. Q3, 88 plus 90 divided by 2. Q3 is 89. Okay? Once you have Q1 and Q3, you can get your IQR. I know some of you guys are still writing. I'm going to just flip the slide, and I've got one more example. It'll be quick, okay? And I'll get you guys out of here on time. So, you know, what do we do if we have an odd n, okay? If n is odd, okay? Well, what we do there is we still do the same thing. We find the spot, we find n divided by 2, and then round down. Okay? So let's say I have 15 values, okay? And so, you know, I'm just going to make up some values. I got 60, 62, 64, 70, 75, 77, 79, 80, 82, 84, 86, 86, 88, 90, and 95. I think this is 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? So to find the median, n is equal to 15. N over 2 is 7.5. We round down, and we get 7. So now what I'm going to do is I'm going to find the spot where 7 are lower and 7 are higher. 7 are smaller and 7 are larger. So I count and I go 1, 2, 3, 4, 5, 6, 7. I draw a line there and I count over here 1, 2, 3, 4, 5, 6, 7. So I've got 7 larger that way, 7 smaller this way. Okay? And therefore my median here is 80. Okay? And then for the quartiles, don't include the median and you do the same thing, okay? So do not include the median to get your quartiles. So you'll do, you'll say 3 this way, 3 this way. Your Q1 is 70. We'll do the same thing over here. Oops. Okay, so we will end here, and we'll see you guys on Friday.